In this recording, we're going to look at quadratic regression. We're going to do a model, create a model, to compare the speed in miles per hour to the average fuel economy in miles per gallon. So if you've had any experience as a driver, or you've ever looked at a car's fuel economy, this is an interesting question. You're at a point where you're either driving or you're about to be driving, maybe look at cars, start noticing price of gas, that kind of thing. So let's investigate a little bit. These are all speeds that, is reasonable for a car to be traveling. And we don't know what car this is, but it'll be interesting for us to see what is the relationship and why we'll model it with a quadratic function. So the first part says, enter the data in your graphing calculator. So grab that calculator, and I'll walk you through the process for getting the data in there. First off, we're going to get data into the calculator by pressing the Stat button, which is right here. Okay? We're going to hit Edit. Now, if there's already some data in there, you're going to need to clear it. So let's imagine I've got some data, 693. Okay? I need to bring my cursor up on top of the heading for that column, hit Clear, Enter. All right, you don't want to hit Delete because it deletes your whole list. So if I come up here and hit Delete, now I don't have an L1 anymore. They're like, oh shoot, what happened to L1? Is it gone? Is the calculator broken? No, you can bring it back. You just have to hit Stat and then Setup Editor, which is choice 5. And then it will run the Setup Editor when you hit Enter. And when you go back to Stat, you'll see, all right, I've got my L1 back. So make sure you've got L1 and L2. Those are the two lists we're going to use right now. I'm going to enter the data into L1 for the X and L2 for the Y's. You should do the same. Play the recording when you're ready. Okay, so at this point, I've got the data entered, and I'm going to just double check that everything is entered correctly. It can be extraordinarily frustrating to have entered some data, think you're good, and then in fact have a typo, and that's going to mess everything up. So I'm just going to double check here, and you can see right off the bat I have an error. That should have been a 15. It's an easy fix, but you won't catch it unless you go in and double check. So I'm just going to check that these are all going by 5s. All the way down it looks like they are. I'm going to check my other numbers in the Y column as well. Alright, so I'm satisfied that those are all entered correctly, and now we're going to proceed to the next part. So it says make a scatter plot using your graphing calculator. So to create the scatter plot, we are going to go to Second Stat Plot and hit Enter. Right now, it says the plot is off. You want it to be on. That particular type is perfect. Our data is in L1 and L2, so that matches the lists. The mark is of your choice. I personally kind of like the box because we're going to have a curve that is going potentially on top of some of these marks. Having a dot as small as that one, you won't see it if it's covered by the curve. And the color, well, whatever you like, if you have color. All right, so now we're going to hit Zoom. And you're going to scroll down to choice 9, Zoom Stat. That's going to give you a perfect window so that you can display all the data. And you can see, it does make kind of a parabolic shape, which is perfect. We're going to model it with a quadratic function. All right, so check to enter the data, check for scatter plot. Use the calculator to create a quadratic function that models the data. So we know some things about the data, right? Or about the function. Think about what you already know about it, given that the parabola is oriented like this, like an upside-down U. And hopefully you identify that the leading coefficient, the A value, needs to be a negative, right? I can't really tell based on the scale anything about what the y-intercept would be or anything like that. But we will let the calculator calculate a function that fits this data pretty well. So let's hit Zoom and, excuse me, not Zoom. What am I doing? Stat. And then Calc, and then you're going to scroll down till you see a quadratic regression. So choice 5 looks pretty good, right? Hit Enter, and we're going to hit Enter, and it gives us a quadratic regression. So I'm just going to take a little screenshot of that so that I have that information. Okay, and let's just paste that here. Great. So we'll just keep that there for a moment while we jot down the information on part C here. It wants us to write down the quadratic function. So basically you're going to take that template, and wherever you see A, you're going to write in this value of A, rounding to the nearest hundredth. So write that down, then play the recording when you're ready. Okay, so if we had something like this, y equals, if you didn't write this yet, you better stop and write it down. All right, so we said it was going to be a negative. It is. I like to put a leading 0 in there. So 0, 1. So very small, wide parabola in terms of the vertical compression. X squared plus 0.75x plus 13.47. Okay, so there's our function. Now I can get rid of this piece of the graph there. All right, what does the quadratic indicate about the relationship between speed and gas mileage? Okay, well, think about that for a second, then play the recording when you're ready. Okay, so hopefully you thought about that and maybe looked at the graph or looked at the table. Let's look at that graph for a second. All right, so as we go faster on the highway, you talk about highway miles per hour, right? You're getting better fuel economy than driving slowly, right? What we call city traffic. But after a certain point, you start going at such a fast rate that it's actually using a lot of gas. So out here at speeds like 65 and 70, it's using more gas than if you're going slower speeds, like 40 or something like that. And we can kind of see there's an optimum point somewhere here in between 35 and 45. You're getting to a high point in terms of fuel economy, which is great, right? 30 miles per hour, 30 miles per gallon is not bad at all. All right, so let's jot that down. Okay, so we said the faster you go, the better the fuel economy, up to a certain point, near 40 miles an hour, when the fuel economy begins to decrease. All right, graph the function on your calculator, sketch the function below. All right, so we'll go back to our calculator. I want to put that function in. All right, so we're going to go into our y equals. Go ahead and enter that function, then hit graph. Okay, you can tell that I neglected the negative sign, so that's an easy fix. Second int gets my negative sign in there. All right, let's give it another try. Much better. All right, cool. It doesn't quite get up as high as I thought it would. In fact, it doesn't quite model that data that well. Let's see if I made a typo in here. Well, after a little exploring, here's what I found out. It turns out rounding off that leading coefficient to 0.01 rounded it too much. It didn't fit the curve very well. So even though it said round to the nearest hundredth, I'd like you to change that. You can do that by inserting. Again, you can hit second ints. You can go in here to the place you want to insert it and make your leading coefficient be negative 0.008. That's going to fit it a whole lot nicer. Check out that fit. Much nicer. Much more precise. Okay, so let's come back here, and even though it says to the nearest hundredth, let's just change this in here and just touch that up a little bit and change that leading coefficient to match the precision that we saw was necessary in order to give us a decent fit. So we'll call it y equals negative 0.008. Having trouble making that 8. Let's try it. There we go. All right. So, check, and now we just need to make the sketch below. So go ahead and sketch that out using the scale that you can see by pressing the window key. Okay, so one more time, if you press window, that shows you, okay, the x-axis is going from that min to that max, the y is going from that min to that max, and I want you to sketch something that matches that. All right, so we've got that sketch, and now we've got the scale all indicated on the y and the x-axis, as well as labels on there. Now it says use the graphing capabilities to find the speed that maximizes the fuel economy. Well, in order to maximize the fuel economy, that should be this point right up here. And we said on our table it should be somewhere around 40, right? Let's go to our graphing calculator and figure it out. So we're going to hit second calc. You're going to look at maximum, which is choice 4, and it wants a left bound. So you need to be somewhere to the left of that maximum point that you can visually identify. So you're going to hit enter, and now you need to move to the right, because it says at the bottom here right bound. So move to the right a bit, anywhere to the right of that maximum point, enter. Now you can see there's 2 bounds created by those dotted lines. Now your guess, anywhere in here close will do. All right, just hit enter, and now it came up with a maximum of 46.875. Okay, 46.875 is our speed that will give us the maximum. All right, so it says indicate that on your sketch. So that's right here. That's going to be our axis of symmetry, right? X equals 46.875. All right, miles per hour. Cool. All right, the final 2 tasks are algebraic. Find the maximum fuel economy using your model, and that means the y value, and predict the fuel economy for a car that travels at 42 miles per hour. Use your model. All right, so figure those out. Play the recording when you've got it. All right, so you're just going to make a substitution and work out. So I'm going to substitute in for x and do the math. Okay, so you just make that substitution, then let your calculator do the work. And I'm going to show you a really cool technique over here on the table. You can hit second table set, and you can have your independent variable ask. So now when I go back to the table, I put in that particular x value, which was 40, you gotta remember, 6.875. Hit enter, and it automatically tells me the y. So 31.048 is the best fuel economy we can expect to get on this car. Equals 31.048. Don't forget your units, miles per gallon. Finally, do the same for a car traveling 42 miles per hour. All right, so I'm just going to grab what I had here, bring that down. What I need to do is just change the x value, right? Just change that x value to be a 42. So hopefully you already worked this part out. That's why I'm going through it kind of fast. That's now a 42. Now the cool thing about our table is pop over here. You want a different x value? 42. Bang, gives me the y value. 30.858 is a good prediction in miles per gallon. 30.858 mpgs. Okay, so now you're wondering, how do I get my calculator to be back so it's not always in this mode? Well, hit second table set, and you can change it back so the independent variable is on auto. And that's it. Thanks for watching.